everyone, welcome to this video lesson on observing matter. Within this lesson, we're going to be looking specifically at learning target 1.2, and the goal by the end of these notes is to be able to observe matter using physical and chemical properties, as well as looking at physical and chemical changes too. Now, we'll be doing more practice with these concepts Monday and Tuesday in class next week, and then you guys can anticipate a learning target 1.2 quiz towards the end of next week as well. Okay, so looking at physical properties of matter and what they really are. So they are properties that can be directly observed without causing any change to the matter. So still at the end of the day, you still have the same substance. A lot of the times you can observe this using your five senses. Your senses such as sight, hearing, taste, touch, and smell. Now, within chemistry class, we're not going to be tasting any chemicals in labs, so we can go ahead and just eliminate that sense, but we will be observing things using sight, hearing, touch, and smell. Now, examples of physical properties are hardness, flexibility, brightness, boiling point and melting point. We'll be using that a lot in class. Density, looking at the length of an object, fluidity, electrical charge, the pressure, volume, area, conductivity if it has electrical charge, and the luster of the object as well. So all these are just different examples of physical properties of ones that we can observe within a lab setting or ones that we can also measure as well. Okay. Now looking at a chemical property. Okay, now the chemical property is very opposite of a physical property. So it's a substance ability to undergo a change. Okay, so meaning you're ending with something completely different. You're changing that matter. Okay, so a substance ability to undergo change that makes it into a different substance. So basically it's any property that defines how it will behave as a chemical. So in the image below, we see three different examples of metals. So in the first one, it says zinc reacts with an acid. So in that picture, solid zinc was dropped into an acid, and we can see from the image that we see a chemical change. In the next one, it says sulfur burns in air. So meaning burning sulfur changes it into something different or into a different substance. Now, the rusting of iron is iron actually oxidizes in air, so that would be the physical or the chemical property of iron. So all three of these examples of zinc, sulfur, and iron are looking at the chemical property of that specific metal. Now, other examples of chemical properties that we'll be looking at in lab, the first one is heat of combustion. And that is basically how hot can something get in order to catch on fire. So kind of think of fire for that one. Reactivity with water, whether it reacts with water or not. pH, meaning if something is acidity, so thinking of acids and bases. Flammability, so if something can catch on fire or if it's fire resistant. Toxicity, chemical stability, and then enthalpy of formation. Now, enthalpy is something that we'll talk about a little bit later on in the semester, but when you see the word enthalpy, enthalpy means energy. So then enthalpy of formation is really looking at the amount of energy it takes for a substance to form. Okay, so moving on now to physical and chemical changes and going over examples of them. Okay, so a physical change is a change where no new substance is created. So looking at the picture down below, we can see we have a picture of copper wire, and then we have a picture of melted copper. Now going from copper wire to then melting the copper into a liquid form, at the end of the day, it still is the same substance. Same thing as if I take a piece of paper and I rip it in half. It is still paper, but now I just have two halves of paper. Also the same thing as in boiling water. Yes, there might be phase changes of those water molecules, But again, at the end of the day, it is still that substance of water. So kind of a key thing when you're thinking of physical change is that all we're really doing is changing what that substance looks like, but it still is that same physical element or compound that we started with. Okay, so probably one of the most common examples of physical changes is the changes of state of solid to liquid to gas. Now, ones that you're probably most familiar with are going from freezing or solidification, that's going from a liquid to a solid. Going from a solid to a liquid would be melting. Going from a liquid to gas would be evaporation. And then going from gas to a liquid would be condensation. Now, those are the ones that you guys are probably familiar with. The ones that might be new would be sublimation and deposition. Now, sublimation is when you're going from a solid to a gas. And a lot of times you're going to see this within dry ice. Now, deposition is when you're going from gas to a solid. And a lot of the times you're going to see that within the fall or in early winter times. For example, when you see like frost on grass early in the morning. Okay, it's all due to that deposition of the gas going to the solid. Okay, so now moving on to chemical changes. So a chemical change is a change that causes a new substance to form. Okay, so kind of a key thing when you think of chemical changes, I always think of it as something that's irreversible. You can't go backwards. Okay, so in the picture below, if I mix baking powder with sugar and chocolate and water and oil and I bake it, I'm going to produce brownies. Okay, and when I look at those brownies, if you think of a chemical change, think of it, it's irreversible. I can't take those delicious brownies that were just made in the oven and break them back apart into their individual pieces of, I can break it back down into baking soda, sugar, oil, and chocolate. Okay, so a lot of the times within chemical changes, what is actually happening is we're changing the arrangement of those atoms and how they're specifically bonded together. Okay, so we're breaking bonds and we're rearranging the atoms to create something completely new. Okay, so looking at signs of chemical changes. So what are different signs that is kind of telling us that a chemical change is happening in lab? And the first one is that when heat is given off or taken in. Okay, and this is without heating that substance. So looking at endothermic and exothermic, which are terms that we'll look at again later on in another unit. But in endothermic, it's looking at taking in heat, and exothermic is looking at giving off heat. And again, both of these are spontaneously. So it's when I'm mixing two liquids and two substances together, if I notice on its own that the solution is either hot or cold, then that can be a sign of a chemical change has occurred. Okay, another sign of a chemical change would be the sign of a precipitate, if that is formed. Now, what a precipitate is, as we can see in the image to the right, is really the formation of a solid. Now, a precipitate is basically that is formed when you are mixing together two liquids. So it's forming a solid where one really wasn't before. Okay, so if I take two liquids and pour them together and I see a solid form, then that would be example of a formation of a precipitate, and that would be example of a chemical change for those two liquids. Okay, key thing of a precipitate, it doesn't necessarily look like a solid. The solution, for example, within this test tube, it looks more like a liquid cloudy substance. Okay, so a precipitate would be an example that a chemical change has occurred. Okay, another sign of a chemical change that we will observe in lab is when a gas is given off. Okay, so what this means is that you're going to see bubbles, okay, in a chemical reaction. So within this image off to the right, we see in the test tubes. In the first test tube, we just have a liquid. Okay, when we mix it with the solid, we see within my product that you're going to see bubbles. And basically what the bubbles are telling you is that a gas is forming, but the key thing is that it's forming without any heat. Okay, so when we see this within lab, it would be a good indication that a chemical change is occurring here as well. Okay, and again, how we see that gas is given off in a chemical change is a lot of times you're going to see bubbles being produced. Okay, and the last example of a sign of a chemical change would be if we see a color change. Now, key thing about this is when we're looking at a color change, it's when we are mixing two clear liquids, and when we mix them together in the product, we're going to see an evident color change. Okay, so that would be an example of a chemical change. Now, understand this is very different than if I add food coloring to water, because when I add food coloring to water, for example, if I add red food dye to a beaker of water, that dye was already red, and basically I just changed the water red, because at the end of the day it's still water. Whereas if I'm seeing a color change and it's an evidence of a chemical change, well, that is going to come from two clearless liquids, and then in my product, I'm going to see something completely different. I'm going to see that evident color change when I started with something that was both clearless. Okay. All right. So that is the end of the notes for today, looking at physical and chemical properties, as well as physical and chemical changes and different examples of them. We will be doing more practice with all of this next week in class. If you guys have any questions about the notes, go ahead and write them in the comments below. But I will see you in class. Have a good one.